Identify the stationary points on the curve y is equal to x cubed minus 3x plus 2. And for each point, determine whether it is a maximum, a minimum, or a point of inflection. So the first thing you're going to do is, when at a stationary point, dy dx is equal to 0. So at a stationary point, dy dx should give us 0. So it means we're going to have to obtain dy dx for this case. So dy dx is going to be, just differentiate that, 3x squared minus 3. So at stationary points, 3x squared minus 3 should be equal to 0. So we can try and solve for x in this case so that we know those points and the stationary points. So what we're going to do, we're just going to factor out 3, so that we have 3 into x squared minus 1 is equal to 0. So we can simplify the value in the bracket using the quadratic identities. We know that when you have a plus b times a minus b, you will get a squared minus b squared. So that is from quadratic identities. So we can employ that to simplify that quadratic equation. So we can rewrite that as 3 into x squared minus 1 squared is equal to 0. So this is like that. So we can write it as 3 into x plus 1 into x minus 1 is equal to 0. So if you divide both sides by 3, you're going to have x plus 1 times x minus 1 is equal to 0. So when x plus 1 is equal to 0, it means that x is equal to negative 1. And when x minus 1 is equal to 0, it means that x is equal to 1. So we can find the values of y from these two x's. So the first one, when x is equal to negative 1, y will be negative 1 cubed minus 3 into negative 1 plus 2. So that is minus 1 plus 3 plus 2. So that will be 4. Then when x is equal to 1, y will be 1 cubed minus 3 into 1 plus 2. So that is 1 minus 3 plus 2. That is 0. So it means the stationary points are, the first one is when x is negative 1 and y is 4, and the second one is when x is 1 and y is 0. So we are going to determine which one between the first one and the second one is a maximum and which one is a minimum. So what we are going to do, we are going to draw a diagram. So for the first case where we have negative 1, 4, we are going to have the value of x, the value of dy dx, and then the diagrammatic representation there. So we're going to pick a point to the left and a point to the right of negative 1. So from the Cartesian plane, to the left hand side we have minus 2, and to the right hand side we have 0. So let us look for the value of dy dx for each of these cases. We know that negative 1 is a stationary point, so at stationary points dy dx is equal to 0. So when x is negative 2, we just substitute that value in our dy dx equation. Our dy dx is 3x squared minus 2. So it means that when x is negative 2, we have 3 times 4 minus 3, which is 9. And when x is 0, we have 0 minus 3, which is minus 3. So it means when this is positive, we have a positive gradient, and then we have a 0 for the gradient there, and then when it is negative, we have a negative gradient. So it means that this is the maximum point because it goes like that. So it means our maximum point is negative 1, 4. So let us try the other point. The other point is this one here, 1, 0. So we again draw the diagram. We have x, we have dy, dx, and then we have the diagram. So we have 1, and to the right of 1 we have 2, and to the left of 1 we have 0. We know that dy dx for a stationary point is 0. So when x is 0, our dy dx will be 0 minus 3. So we have minus 3. And when x is 2, we have 3 times 2 squared, that is 3 times 4, that is 12 minus 3, that is 9. So at first, when x is 0, we have a negative gradient. So it goes like that. And it is 0, we have a flat one for the gradient. When it is positive, we have that. So it is like that. So this is a minimum point. So it means our minimum point is 1, 0.